Industrial power demands precision. Every connection, every component, and every decision matters when you're dealing with high-stakes electrical systems. In this environment, even the smallest oversight can have major consequences. There's no room for error. A single mistake can lead to equipment failure, costly downtime, or even put lives at risk. That's why attention to detail is absolutely critical. Today, we're assembling a panel designed to run 8 single-phase motors and 2 three-phase motors. Each motor has unique requirements, and the panel must be tailored to handle the specific loads, voltages, and safety needs of each one. Mistakes here aren't just costly, they're dangerous. An incorrectly wired panel can cause fires, electrical shocks, or catastrophic equipment damage. That's why we take every precaution from the very beginning. It's not just about connecting wires, it's about understanding the flow of electricity, the logic of the system, and the importance of every single connection. We're building a system that's safe, reliable, and efficient for years to come. Proper planning and execution now mean fewer problems and safer operations down the line. The real work is what you don't see. Clean, organized wiring, properly sized breakers for each circuit, and careful attention to every detail behind the panel door. Safety devices like relays and circuit breakers are the silent guardians, protecting both people and equipment from unexpected faults or overloads. This panel is the nerve center of your operation, distributing power efficiently and safeguarding everything connected to it. Without a solid foundation here, the entire system is at risk. We'll walk through the process step by step, focusing on doing it right. No shortcuts, no guesswork. Every step is deliberate. Every check is essential. From the initial layout to the installation of safety components, every detail matters. A well-thought-out design makes future maintenance easier and keeps everyone safer. Safety is always the top priority. Before you even touch a wire, make sure you're protected and the system is secure. Before starting, always disconnect the main power. This simple step can prevent serious accidents and save lives. And don't forget your protective gear. Gloves, goggles, and insulated tools are your first line of defense against electrical hazards. If you're ever unsure, consult a licensed professional. There's no shame in double-checking your work or asking for expert advice. Safety and accuracy always come first. Our goal is a panel that's not just functional, but a fortress of safety, robust, secure, and built to last. Let's get started and build it right from the very first step. Every action you take now sets the standard for the entire system. Here's your blueprint for a professional panel. Follow along and you'll have the confidence to build a system that stands the test of time. Before you even touch a wire, take a moment to plan your space thoroughly. Organization isn't just about neatness. It's the foundation of safety and efficiency in every electrical project. A well-thought-out layout prevents mistakes and keeps you, and anyone who works on the panel after you, safe from hazards. Begin by installing DIN rails. These sturdy metal strips are the backbone for all your electrical components, providing a secure and standardized mounting surface for everything from circuit breakers to relays. Carefully measure the space inside your enclosure, cut the DIN rails to the correct length, and mount them straight and level. Precision here is crucial. Crooked rails can cause alignment issues and make future work much harder. Always leave deliberate gaps between components for airflow. Overcrowding your panel can lead to overheating, which not only shortens the lifespan of your equipment, but can also create dangerous conditions. Next, install wiring ducts. These plastic channels are essential for keeping wires organized, separated, and easily accessible. They help you route cables neatly and prevent accidental damage during installation or maintenance. Good ducting is the difference between a tidy professional panel and a tangled mess. It not only looks better, but also makes future troubleshooting and upgrades much easier and safer. As you plan your layout, position the main power switch at the top for quick access in emergencies. Group miniature circuit breakers, MCBs, together logically, so anyone can quickly identify and isolate circuits if needed. Place controllers, such as PLCs, and terminal blocks in logical, accessible locations. Clearly label each one to avoid confusion and speed up any future work. A clear, well-organized layout means that anyone, whether it's you or another technician, can understand your work at a glance, reducing the risk of errors and making maintenance straightforward. Don't rush this stage. Take your time to double-check measurements and component placement. Careful planning now can save you hours of frustration and rework later on. Use a level and tape measure for every installation. Precision tools ensure that everything lines up perfectly, which is essential for both function and appearance. A spotless, well-prepared foundation sets the standard for the entire project. It's much easier to maintain high-quality work when you start with a clean, organized base. Remember, this isn't just about making things look good. Proper organization and secure mounting are critical for safety, reliability, and the long-term performance of your electrical system. Quality always starts with the basics. Laying a solid foundation now ensures every step that follows is easier and more effective. With your rails and ducts perfectly installed, you're ready to move on to the heart of the panel, where all your careful planning comes to life. Now, let's focus on installing the panel's safety core, RCCBs and MCBs. These components are the backbone of electrical safety in any industrial setup, and their correct installation is absolutely vital. Take your time to ensure each device is properly seated and securely fastened. The RCCB, or residual current circuit breaker, is your first line of defense against electrical hazards. It constantly monitors the flow of current and instantly cuts off power if it detects even a small leakage, protecting lives from electric shocks and preventing potential fires. This quick response can be the difference between a minor incident and a major disaster. For three-phase circuits, always use a 4-pole RCCB, while a 2-pole RCCB is suitable for single-phase circuits. Choosing the right type ensures comprehensive protection for every part of your system, whether you're dealing with heavy machinery or standard equipment. Snap each RCCB and MCB firmly onto the DIN rail. Make sure they're aligned and locked in place, as a loose connection can compromise safety and lead to equipment failure. Next, add the MCBs, miniature circuit breakers. Install one MCB for each single-phase motor and two 3-pole MCBs for the 3-phase motors. This setup ensures that every motor, regardless of its type, is individually protected from electrical faults. MCBs are designed to trip automatically during overloads or short circuits, preventing damage to your equipment and reducing the risk of fire. They act as guardians for your machinery, ensuring that any electrical fault is quickly isolated. Group and clearly label each MCB for easy identification. Proper labeling is crucial, not just for day-to-day operation, but also for maintenance and emergency situations. It allows anyone working on the panel to quickly locate and isolate circuits, saving valuable time and preventing mistakes. Together, the RCCB and MCBs create a robust, two-layered safety system, one that protects both people and equipment. This layered approach is a hallmark of professional electrical panel design. Always match breaker ratings to the wire size and the expected load. Never guess or assume. Using the wrong rating can lead to overheating, equipment failure, or even fire. Double-check every connection and rating before moving on. Remember, these safety devices aren't optional. They're essential for building a professional, reliable, and safe electrical panel. Skipping or misinstalling them puts both people and property at risk. Pay close attention to every detail during installation. Careful wiring, secure terminals, and thorough inspections at this stage can prevent costly and dangerous disasters down the line. With the core safety measures in place, your panel is now ready for the next step, protecting your motors with current controllers. Let's move forward and ensure every aspect of your system is safeguarded. Motors need protection from overloads. Enter current controllers. These devices trip if a motor draws too much current for too long, preventing costly damage. Install one controller for each motor right after the MCBs on the DN rail. Set each controller to match the motor's full load amperage found on the nameplate. Too low and you'll get nuisance trips. Too high and you lose protection. This step is non-negotiable for equipment safety. Together with RCCBs and MCBs, current controllers form a complete protection system. Skipping them is asking for trouble. Protecting equipment is as important as powering it. Now let's wire the emergency power switch. Stay sharp, this is critical. Power outages can halt production and create hazards. A changeover switch lets you safely switch between city power and a generator, never connecting both at once. Install the switch in a prominent spot in your panel. Wire city power to one set of terminals, generator to another, and outputs to the panel's main bus bars or RCCB. The switch's design prevents dangerous backfeeding. Double-check all connections. Mistakes here are costly and dangerous. In an outage, move the switch from city to off, then to emergency power. When grid power returns, reverse the process. This manual switch is simple, reliable, and essential for any critical operation. Preparation is key. Don't get left in the dark. Next, let's add a warning system. Stay alert. An alarm system gives instant notice when grid power fails, crucial in noisy or automated environments. Use a buzzer or light powered by a backup battery or UPS. A relay, energized by city power, keeps the alarm off. When power fails, the relay triggers the alarm. Mount the relay and alarm on the DN rail. Connect the relay call to city power and the alarm through the relay's normally closed contacts. This setup ensures the alarm only sounds during a true outage. Quick, clear alerts mean faster, safer responses. Small details like this make a big difference. Now let's wire the motors. Precision matters here. Time for the heavy hitters, wiring the three-phase motors. Each needs 3 hot wires, L1, L2, L3, a neutral and a ground. Connect from the 3-pole MCB and current controller to the motor's terminal box. Get the phase sequence right, swap 2, and the motor runs backward. The neutral is essential for RCCB protection. Never skip it. Tight, secure connections prevent overheating and failure. Double-check rotation direction and documentation. Repeat for the second motor. Meticulous wiring here ensures safety and reliability. Next, single-phase outputs. Let's keep it balanced. Now, connect the 8 single-phase motors, workhorses of your facility. Distribute them across the 3 phases to balance the load. 3 on phase 1, 3 on phase 2, 2 on phase 3. Each motor gets a hot wire from its MCB and controller, plus neutral and ground. Use a neutral bus bar for tidy, secure connections. Correct wire size is critical. Undersized wires are a fire risk. Tighten all connections and avoid stray strands. Label each circuit clearly. Review your work. Balance loads, solid connections, clear labels. Fundamentals matter. This is how you build for longevity. Final step: inspection and testing. Let's finish strong. Assembly's done, but the real test is inspection and power up. Check every terminal and connection for tightness. Confirm all labels are clear and accurate. Use a multimeter to check for shorts and continuity before energizing. Test the emergency switch and alarm relay manually. Power up the main RCCB first, then each motor circuit one by one. Check voltages, motor rotation, and running current. This careful process ensures safety and reliability. Every component, from rails to relays, plays a vital role. Proper checks aren't just best practice, they're essential. You've built a professional, safe panel. Congratulations, you made it right.